So good day everyone, this is Myra M. Korong, and today we're going to discuss about the F-test or the ANOVA. So first we're going to define what is ANOVA. So what is ANOVA or the F-test? F-test is the analysis of variation or the ANOVA. F-test is also a parametric test which has to meet some conditions and data to be analyzed if they are normal and expressed in an interval or ratio data. Analysis of variance or ANOVA is an analysis tool used in statistics that splits an observed aggregate variable found inside the data into two parts: the systematic factors and the random factors. The systematic factors have a statistical influence on the given data set, while the random factors do not. So that is F-test or the ANOVA. So when are we going to use ANOVA? Where do we use ANOVA? So if we want to compare multiple population, it's not just easy to compare a population because it is a wide range. ANOVA is perfectly in. So with ANOVA, we can compare multiple population and even subgroup in those population. We can investigate how these two population interact quantitatively. Analysts use the ANOVA test to determine the influence that independent variables have on the dependent variable in a regression study. So there are two main types of ANOVA: the one-way ANOVA and the two-way ANOVA. So one-way ANOVA is used when there is only one variable involved. The one-way ANOVA is used to determine whether there are any statistical significant differences between means of three or more independent unrelated groups. The two-way ANOVA is an extension of one-way ANOVA. So with two-way ANOVA, there are two independent. So that is the two main types, one-way and two-way ANOVA. Also, there are also variations in form of ANOVA. For example, the MANOVA or multivariate ANOVA differs from ANOVA as the former tests for multiple dependent variable at a time. So that is the types of ANOVA. So where are we going to use ANOVA? As what I've said, yes, there's what its limitation. Everything has a limitation, and ANOVA has a limitation also. So in one way, ANOVA will tell you that at least two groups were different from each other, but it won't tell you which group were different. If a test return a significant F-test, you may need to run an ad hoc test like a least significant difference test to tell you exactly which group had a difference in mean. A two-way ANOVA is an extension of one-way ANOVA. With one-way ANOVA, you have one independent variable affecting the dependent variable. With two-way ANOVA, there are two independents. Use a two-way ANOVA when you have one measurement variable, example the quantitative variable, and two nominal variables. In other words, if your experiment has a quantitative outcome and you have two categorical explanatory variable, a two-way ANOVA is appropriate. So that is where are we going to use ANOVA. So why? So can you just simply compare the population? Oh, that is too wide. So if you want to compare things in an easy way, especially population, the ANOVA is perfectly right. In comparing population more than two of the population or the subgroup of this population, the ANOVA is perfectly in to tell if the means same from overall population. So independent sample t-test random, you can have that, or match sample t-test paired. So that is why are we going to use ANOVA.
So this time we will try to solve our F-test ANOVA, and I will show you how we can um, solve this problem. So our data is the number of minutes that a patient had to wait for their appointments with 5 doctor. So we have here 5 group represents the 5 doctor, and we're going to use the 0.5 k. So we have here the minutes that the patient had to wait with their appointments in different 5 doctor. So first, we're going to state the problem. So the problem is there a significant difference in the number of minutes that a patient had to wait for their appointment? So that is the first, to state the problem. Second is to write our hypothesis. So we have here 2 hypotheses. The first hypothesis is there is no significant difference in the number of minutes of the patient had to wait for the appointment with 5 doctors. And the second is there is a significant difference in the number of minutes of the patient had to wait for their appointment with 5 doctors. So the third is we're going to solve for our degree of freedom. So the third step is the level of significance. We're going to use the 0.05. And for our degree of freedom, we need the number of group. So we have here group 1, 2, 3, 4, 5. So we're going to write the number of group 5 and subtract it to 1. And we have here 4. So here, for the degree of freedom, we need our number of samples, subtract the number of groups. So we have here number of samples. So 5 plus 5 plus 5 plus 5 plus 5. In each group, we have 5 samples. So 5 times 5 is 25. So 25. Subtract it with the number of groups, which is our number of groups is 5. 1, 2, 3, 4, 5. So let's just subtract it. And we have 20. So our degree of freedom is 20 and 4. Here's the 4, here's the 20. So number of groups is 5. Number of samples is 25. Subtract the number of groups. So we have, we're already done with level 3, level of significance. This time we are in a 4th step. So our first step is statistics. So we got the group 5 here from our data here. So I copy the group 1 data here, group 2 data, group 4 data, and group 5. So represents A, B, C, D, E with 5 groups. So now, as you see, there's a squared here. So the number of 21, we just need to square it, and that is the answer here. So let's do it all together here. So 21 squared is 441. So this is how it goes. So let's continue. So 20 squared is 400, 21 squared is 441, 30 squared is 900, 28 squared is 784, 9 squared is 81, 11 squared is 121, 15 squared is 225, 12 squared is 144, 18 squared is 324. So 18 squared is 324, 17 squared is 289, 16 squared is 256, 15 squared is 225, 20 squared is 400. 9 squared is 81, 11 squared is 121, 20 squared is 784, 30 squared is 900, and 15 squared is 225. So 29 squared is 841, 30 squared is 900, 24 squared is 576, 26 squared is 676, and 28 squared is 784. So, just like that. Every number here, we just squared it by itself, and then we came into x2 squared, x1 squared, x2 squared, all the way to x5 squared. This time, we're just going to add this and this all the way here and get the sum so that we can write the sigma x1. So it is the total of this group. So if we add all of this, we get the sigma x1 is equal to 120. If we add the x1 squared, it will be equal to sigma x1 squared to 2966 and all the way down there. So x2 is equal to sigma x2 65. So x2 squared is equal to sigma x2 squared of 895. So x3 is equal to sigma x3 86. x3 squared is equal to sigma x3 squared of 1494. X4 is equal to sigma x4 93. The x4 squared will be equal to sigma x4 squared 2111. X5 is equal to sigma x5 137, and x5 squared will be equal to sigma x5 squared 3777. So let's continue. We need our n. So what is our n? So our n is just the number of group, which is 5. So it's just in one group. So we're going to use n all the way down there is 5. So there it is. The number of group is 5. There is just one group. So we're going to use, and each of this group is 5. So because we're just representing 5 groups. And let's continue. And able to get the x1, so we just need our x1, sigma x1 divide into our n, so we can have here, so what is our x1? 120. So let's just divide it with our n1, which is 5, and we can have our x1 will be equal to 24. So in group A, we have x1 of 24. So the same here, we have sigma x2, which is 65, divided with our n2, which is 5. So we have sigma x2 will be equal to 13. So next is the group 3. Our sigma x3 is 86, divided with our n3, which is 5. And we have x3 of 17.2. Yes, 2. So next, we have here the x4. So we need our sigma x4, which is 93, divided with our n4, which is 5. And we can have our x4 will be equal to 18.6. So next, our x5, we need our sigma x5, which is 137, and divided with our 5 and 5. And we can have our x5 equal to 27.4. So that is the whole process in the 4 steps, our statistics. This time we are in the 5th steps. So we have here the analysis of f-test one-way analysis of variance, or the ANOVA. So we're going to compute. So we need our sigma x1, sigma x2, sigma x3, sigma x4, sigma x5, and we squared it, then divide it with our n1, n2, n3, n4, and 5. So let's write it. Our sigma x1 is 120, add it with our sigma x2, where? 65. Okay, add it with our sigma x3, which is 86, add it with a sigma x4, 93, and add it with our sigma x5, which is 137, and squared it. So divide it with our n1, 5, n2, 5, n3, n4, and 5, which is just the same 5. 5 plus 5 plus 5 plus 5 plus 5. So we're done here. Next, we're going to solve this. 120 plus 65 plus 86 plus 93 plus 137 is equal to 501, and squared it. And then 5 plus 5 plus 5 plus 5 plus 5 will be equal to 25. So this time, if we square the 501, we can have the 251,001, and if we divide it into 25, we have our computation, which is equal to 10,040.04. So we're done with our computation here. So to get our TSS, or to get our total sum of square, so we just need our sigma x1 squared, which is here 2,966. Add it with our sigma x2 squared, which is here 895, and add it with our sigma x3 squared, which is here 1,494. Add it with sigma x4 squared, which is 2,111. And lastly, add it with our sigma x5 squared, 3,777, and subtract it with our CF, which is 10,040.04. So we can have our total sum of square of 1,202.96. And we're done with our, oh, not yet. So this is our total sum of square. So this time we're going to get our between sum of squares. So we need our sigma x1, 120, squared it, and divide it with our n1, 5. Add it with our sigma x2, which is 65, squared it, and divide it with our n2, which is 5. And then we have sigma x3 of 86, squared it, and divide it with our n3, which is 5. Next is our sigma x4, 93, squared it, and divide it with our n4, which is 5. Lastly is the sigma x5, 107, squared it, and divide it with our n5, which is 5. Our between sum of the square. Next is we're going to square this 120 squared and divide it into 5, so we can get the 2,880. And add it with our 65 squared, divide 5, which is equal to 845. And add it with our 86 squared, divide 5, which is equal to 1,479.2. Add it with our 93 squared, divide 5, which is equal to 3,753.8. Oh, we're going to subtract it with our CF, just like here in our total sum square. So lastly is our sigma x5, which is 137, squared it and divided into 5, and we can get the, we can get the 3,753, and here 93 squared divided 5 is equal to 1,729.8. Just exchange. The answer of here is here, and the answer of here is here. So add all of this, and what is our CF? Our CF is 10,040.40, 10,040.40, and if we add all of this, we can have 10,687.8, and subtract it with our 10,000 or CF 40.04 to get our BSS, which is equal to 647.76. So that is our between sum of square. This time we're going to get our within sum of square, WSS. We just need our TSS and BSS, which is our TSS is here 1202.96, 1202.96, and subtract it with our BSS, which is 647.76, to get the within sum of square of equal to 555.2. And we're done with step 5, our analysis, ANOVA computation. So let's go to step 6. 6 is decision conclusion. So if the F computed value is greater than or beyond the F tabular or critical value, let's reject our hypothesis. So our F test is computed into 5.833 and our F tabulated is equal to 2.9. So how did I get it? So here's our analysis of variance table. So we have here the source of variation, the between groups and within groups, the degree of freedom, and our sum square, mean of square, and our F value. So we get the 5.83 from our within group of, we just need our BSS, which is 161.94, and divide it with our WSS, mean of square, okay, so 27.76, and we have the total of 5.83 again. So we have our mean square here. We need our mean square BSS divide DF and WSS divide DF, and we have 161.94 and 27.76. So we have our F computed, which is equal to 5.83. So next, where did we get the 2.9? If you're wondering how did I get the tabular F distribution 2.9, it's in our critical value F distribution. We need our degree of freedom of 20 and 4. We have 2.87, and rounded off we have 2.9. So that's all. Oh, step 7, our conclusion. Since is F computed of 5.83 is greater than or beyond the F tabular critical value of 2.9 at 0.5 level of significance with 4 and 20 degree of freedom, the null hypothesis is rejected. To further test our hypothesis, we need our FKFS test to test if there is significant difference in the number of the minutes that a patient had to wait for the appointment with 5 doctor. So here's the equation. F is equal to x1 minus x2 squared divide into xw squared times n1 plus n2 divide n1 and 2. So our AX is 24. Our BX is 13. So let's subtract it and square it like this. And our SW squared, or within sum square, is 5.83. It's in our analysis of variance table. Our within group sum square is 5.83. So 24 minus 13 squared is 121. 5.83 times 5 plus 5 is 10. Divide 5 times 5 is 25. Is equal to 2.332. And if we divide this, 121 divided 2.332 will be equal to 5.83. Just like here, our AX is 24, CX is 17.2. Let's subtract it and square it. And we need our SW squared, 5.83 times 5 plus 5 is 10. Divide 5 times 5 is 25. So it will be equal to 2.332. So if we divide 46.24 to 2.332 will be equal to 19.83. So next is our A versus D. 24 divide 17.2 squared. So our A is 24, our 17.2, D, X is 18, CX, D, our D, 18.6. I'm sorry, 18.6. It will be 18.6. So our dx is 18.6 divided with our SW squared is 5.83 times our AN 5 and DN 5 plus 5 over or divided with our NN, which is 5 times 5. So next is 24 minus 18.6 squared will be equal to 29.16. And 5.83 times 5 plus 5 is 10, divide 5 plus 5 is 10, divide 5 times 5 is 25 will be equal to 2.332. So 29.16 divide 2.332 will be equal to 12.50. So A versus E. So our AX is 24, EX is 27.4. So 24 minus 27.4. Squared it and divided with our SW squared, 5.83. Our AN, which is 5, and EN is 5. Add it and divide it with our NN, which is 5 times 5. So 24 minus 27.4 squared will be equal to 11.56. And 5.83 times 5 plus 5 is 10. So divide 5 times 5 is 25 will be equal to 2.332. So 11.56 divide 2.332 will be equal to 4.95. So next, okay, A versus B. B versus C. So our BX is 13. Subtract with CX, which is 17.2. Squared it and divide it with our SW squared, 5.83. It's here. Divide it with our, multiply it with our NN. BN is 5. CN is 5. So 5 plus 5. And divide it with our NN, which is 5 times 5. So 13 minus 17.2 squared will be equal to 17.64. Okay, and 5.83 times 5 plus 5 is equal to 10. Divide 25, 5 times 5 will be equal to 2.332. And 17.64 divide 2.332 will be equal to 7.56. Next, our B versus D. Our BX is 13. Subtract it where dx is 18.6 squared it. We need our SW squared, which is 5.83. 5.83. Multiply it with our BN and DN, which is 5 plus 5. Divide it with our N. 5 times 5. So 13 minus 18.6 squared will be equal to 31.36. Divide it with our 5.83 times 5 plus 5 is 10. Divide 5 times 5 is 25, which will be equal to 2.332. And 31.36 divide 2.332 will be equal to 13.44. So next, let's use the B versus D. So what is our BX? 13 minus our DX is 18.6, divide our SW squared, which is 5.83, and multiply with our N. BN is 5, DN is 5. So 5 plus 5. And divide it with our NN, which is 5 times 5. So 30 minus 18.6 will be equal to 31.36. 5.83 times 5 plus 5 is 10. Divide 5 times 5 is 25 will be equal to 2.332. And 31.36 divide 2.332 will be equal to 13.44. So our B versus E. What is our BX? Is 13. What are our EX? Is 27.4. Divided with our SW squared, which is 5.83. Multiply with our BN, 5, EN, 5, so 5 plus 5. And divided with our NN, which is 5 times 5. So 13 minus 27.4 squared. Okay. So it will be equal to 207.36 divided with our 5.83 times 5 plus 5 is 10, divide 5 times 5 is 25 will be equal to 2.332. And 207.36 divided 2.32 will be equal to 88.91. So next is our C versus E. What is our C? X 17.2. Subtract it with our EX, that is 27.4 squared. Divide it with our SW squared, which is 5.83. And we need our CN, 5. EN, which is 5. So let's add it and divide it with our NN, which is 5 times 5, and then it will be equal to 17.2 minus 27.4 squared is 104.04. Divided with our 5.83 times 10, 5 plus 5 is 10. Divide 25, 5 times 5 is 25 will be equal to 2.337. And 104.04 divided 2.322 will be equal to 44.61. Lastly is the D versus E. What is our DE? DX, 18.6. What are EX? This is 27.4. Squared it, divided with our SW squared, which is 5.83. Multiplied with our D, N, and E, N, which is 5 plus 5. And divided by our NN, which is 5 times 5. So, 18 minus 6, 18.6 minus 27.4 squared will be equal to 77.44. And divided with our 5.83 times 5 plus 5 is 10, divide 5 times 5 is 25, 2.332. So it will be equal to 77.44 divided 2.332 is 33.20. So here it is, our SKFS test. So next, here it is. The comparison in number of minutes that the patient had to wait for their appointment with 5 doctors. So we have A versus B. Okay, 5.81. Wait. Like that. Oh, no. This our comparison of number that the minutes had that the patient had to wait for their appointment with 5 doctors. Series are between doctors. And our F is just copied from here. the answer of between doctors. And if you're wondering how did I get 11.16, we need our F times our K minus 1 times our tabular, F tabular. So which is our F is 0.5, our K, it's in here. So our F is 0.5, our K is 5 minus 1 will be equal to 4. F tabular is 2.9. So 0.5 times 4 times 2.9 will be equal to 11.6. That's why we have here 11.6. So, in our interpretation, if our schiphestes is higher, then there is significant difference. So, if our schiphestes is lower, there is no significant difference in the number of minutes that the patient had to wait for their appointment with 5 doctor. In conclusion, okay, there is significant difference between the doctors of A versus B, A versus C, A versus D, B versus D, significant, B versus E, C versus E, and D versus E. While our A versus E, B versus C, and C versus D has no significant difference in the number of patients had to wait for their appointment with 5 doctors. So that is all. Thank you. In conclusion, the table shows that there is significant difference between Dr. A and B, Dr. A and C, Dr. A and D, Dr. B and D, Dr. B and E, Dr. C and E, Dr. D and E. However, Dr. A and E, Dr. B and C, Dr. C and D have no significant difference in their number of patients had to wait for their appointments. This implies that the Dr. B has short minutes of time that the patient had to wait for their appointments than Dr. A, C, D, and E. Thank you.